All right, today's lesson is on section 1.2, linear equations in one variable. First, let's talk through some of the vocabulary words. An equation is a statement that indicates two quantities are equal. And we will be seeing equal signs for these. Next, a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers. A is not equal to 0, and x is the variable. Next, the solution or the solution set is a value or values that makes the equation a true statement. And then equivalent equations are equations that have the same solution set. Awesome. Next, before we start, we also need to talk about properties of equality. So we're going to let A, B, and C be real valued expressions. The first property is the addition property of equality. And what that says is A equals B is equivalent to A plus C equals B plus C. So adding the same number to both sides of A equals B, we've added C to both sides. The equations that I highlighted in pink stay equal to each other. An example of this would be if we have x plus 4 equals 9, and we do x plus 4 minus 4, and 9 minus 4, we subtracted 4 on both sides. Because we subtracted 4 on both sides, the two equations stay equal, and we're going to have x equals 5. So all three of these equations here are equal by the addition property of equality. Next, the multiplication property of equality states that A equals B is equivalent to A times C equals B times C. So if we multiply both sides by C, A equals B and AC equals BC are equivalent expressions. Oops, let me erase that. All right, an example of this would be if we have 4x equals 24, and we multiply 1/4 times 4x and multiply 1/4 times 24. We maintain equality because we multiplied by 1/4 on both sides, and we are left with x equals 6. So again, all three of these equations are equivalent because of the multiplication property of equality. All right, let's go ahead and get into some examples. So I have negative 3/4 p equals 2 over 9. I'm going to multiply by negative 3 over 4 on both sides. And because I'm doing that on both sides, we're using the multiplication property of equality, so it will not change the equation solutions. So here, the 3's cancel, the 4's cancel, and then the negative times the negative is just positive, so we're left with p. And then on the right side, if we do 2 times negative 3, we get negative 6. And if we do 9 times 4, we get 36. This is perfectly fine, but it can also reduce to -1/6. Now in the middle one, we're going to multiply by 15. We maintain equality because we multiplied by 15 on both sides. And we're left with W on the right side. And then on the left side, 15 times 5 is 75. We use the multiplication property of equality. All right, on the last one, we're going to add 5 on both sides. And on the right, we're left with Y. On the left, we've got 4 plus 5 equals 9. And here we maintained equality by the addition property of equality. This next section says solve each linear equation and check the answers. So we always we're trying to isolate the variable, and we want to move what's furthest from the x first. So if you notice, the 5 here is touching the x and the 4 is separate, so we're going to move the 4 first. And by doing that, we're going to try to make it equal to 0. So if we add 4, these would cancel out to 0. Anything I do on one side of the equal sign, I have to do on the other. So we're going to add 4 on both sides. And we're left with 5x equals -20. Still trying to isolate the variable, so I need to get rid of the 5. In between the 5 and the x, we have multiplication, so we're going to divide. And we have to do that on both sides to maintain equality. And our solution is going to be x equals -4. Now, online, for your homework, you're probably going to see it written as a set. So this would be in brackets -4. Either one is fine on paper, but I think online you're going to add that as a set. This section does want us to check our answer. So what we're going to do is we're going to take our original equation, and instead of that x right there, we're going to double check that -4 will make that equal to -24 still. So I have 5 times -4 minus 4 equals -24. I'm not sure if it's right, so I'm going to put a little question mark over the equal sign just to be sure. On the left, I've got -20 minus 4 equals -24. Again, I'm not sure, so I'm going to keep that question mark there. And it turns out -4 minus 4 is -24. So we do have -24 equals -24, and we checked our answer. All right, for this next one, there's a little bit more going on. So the first thing we need to do is distribute. So I've got 2t minus 10 plus 4 equals 3. And then on this one's a little trickier. It's kind of like a -1 out here. So I've got -1t minus 2 on the right side. Let's combine like terms before we move on. So on the left, I'm going to have -2t minus 6 because I combined these two. And then on the right side, we have 3 minus 2 would be 1 minus t, or 1t either way. Now we're going to use our properties of equality. So I'm going to add t to both sides. And when I do that, I've got 3t minus 6 equals 1. I'm going to use the addition property of equality and add 6 to both sides. And I've got 3t equals 7. I'm going to divide by 3 on both sides. And I've got t equals 7/3. And again, online, it's probably going to be written like, a set in brackets. Now, they do want us to check our answers in this section. So we're going to plug in 7/3 here and here. It's a little messy because of the fraction. So I'll try to write it clear, but we're going to have 2 times 7/3 minus 5 plus 4 equals 3 minus 7/3 plus 2. And I would just probably do that in my calculator so you don't have to do it by hand. So let me do that real quick. On this left side, I got -4/3. I forgot to put my little question mark there just to be sure. And then on the right side, I'm plugging that in my calculator. And I also got -4/3. So this one does check out. All right, for the next section, we are solving the following linear equations by clearing the fractions. So what we want to do on these, we want to look at the denominators and find what the least common multiple between these would be. And for 2, 4, 3, and 4, we're going to be multiplying by 12. So I'm going to multiply everything by 12 on the left side and everything by 12 on the right side. we have to do on both sides to maintain equality. So here, if I do 1/2 times 12, I've got 12 over 2x. And then if I distribute, I've got minus 36 over 4. Equals, same on the right side, 12 times 2/3. That would give me 24 over 3x. And 12 times 5/4 would be 60 over 4. Let's reduce those fractions. So here we've got 6x minus 9 equals 8x plus 15. Now this is a lot more manageable than trying to deal with the fractions. So I'm going to subtract 8x on both sides. And at the same time, I'm going to go ahead and add 9 on both sides. So I've got negative 2x equals 21. Nope, sorry, 24. And if I divide by negative 2 on both sides, I'm left with x equals negative 12. And again, online, it's probably going to be written as a set in brackets. All right, next problem, we want to clear the fractions. And so the least common multiple of our denominator, we've got 3, 5, and 10. The least common multiple is going to be 30. So I'm going to multiply everything on the left side by 30 and everything on the right side also by 30. So if I distribute here, I'm going to have 30 over 3 times x plus 1. And distribute here, minus 30 over 5 times x plus 3 equals, distribute here, 3 times 30 is just 90. Distribute here, minus 30 over 10 times x minus 3. Let's reduce our fractions. So I've got 10 times x plus 1 minus 6 times x plus 3 equals 90 minus 3 times x minus 3. And then from here, we're going to distribute. I've got 10x plus 10 here. Here, I'm going to have negative 6x minus 18. 90, distribute here. I'm going to have minus 3x plus 9. I'm going to combine like terms. 4x minus 8 equals negative 3x plus 99. I'm going to add 3x to both sides and add 8 on both sides. And this is going to get me 7x equals 107. Divide by 7. X is equal to 107 over 7. And then again, it's probably going to be written as a set. All right, it says solve the following linear equation by clearing the decimals. So very similar to clearing the fractions. Here you notice all the decimals go to the 10th place. So if we multiply everything by 10, that's going to help us get rid of the decimals. Oops. So on the left side, if I multiply by 10, I need to multiply by 10 on the right side as well. So here, that's going to give me 22x plus 5 equals 16x plus 2. I'm going to subtract 16x on both sides. I'm going to subtract 5 on both sides just at the same time. And this is going to give me 6x equals negative 3. Divide by 6. And negative 3 over 6 reduces to negative 1/2. And then it's probably going to be written as a set. All right, the last section says solve the following literal equations for the specified variables. So all this means is you are going to have variables in your answer. So on this first one, it says 2x minus 5y equals 40, and we are trying to get y by itself. So if you notice here, the minus 5 is touching the y, so we want to move the 2x first. And to do that, we're just going to subtract it on both sides. So you've got negative 5y equals negative 2x plus 40. And if I divide by negative 5 on both sides, I'm left with y on the left side. Now on the right side, notice here I divided the whole side by negative 5. And so what you're going to do is you're going to divide each piece by negative 5. So for the first piece, negative 2x divided by negative 5, the negatives just cancel out and you're going to have 2/5 x. And then the second division would be 40 divided by negative 5, and that's going to be minus 8. So we solve for y, and we have variables in our answer, and that's why it's called a literal equation. All right, for the next one, we have v equals pi r squared h over 3, and it wants us to solve for this r. The 3 is in the denominator, so we're going to get rid of that first, and we're going to multiply by 3 to do so. And if we multiply by 3 on the right side, we need to multiply by 3 on the left, so that's going to get us 3v equals pi r squared h, because these 3's cancel out to 1. We're still going for this r here. The little squared symbol is right with the r, so let's divide by pi h first. So these cancel to 1, and we're left with r squared. And then on the left, we've got 3v over pi h. Still going for r, and then to move that square to the other side, we need to square root both sides. So that leaves us with r. And when you square root something, if you think about it, if I take the square root of 25, that would be 5 or negative 5, because also negative 5 times negative 5 would be positive 25. So if we think about that, we are going to have plus or minus the square root of 3v over pi h. And this plus or minus says that there's two solutions here. You can type that as when you do your homework, or you could list it out as two different answers. So I'll just show that off to the side. So our first solution would be the square root of 3b over pi h, and the second solution would be negative square root of 3b over pi h.